So we are going to study information security, right? So we are going to study information security, and I've gotten a reference from this book, Info Security. Like, how do we protect data? What are the principles? And we will do some major topics in the information security. So I've chosen this book based on Principles of Information Security by Whitman and Medard. And the first topic that we're going to study is principles of security design, right? So the question is, how do we really, how do we really design the security for informations that we have? We have really, just surrounded with a lot of information, fetching in, fetching out different data, exchanging stuff. So how do we protect the data which is important to us, or which is important to a person, as data is flowing through different channels? So what is the data that could be recognized as the one which is valuable, like our own data, the message we send to the person we don't want others to see, right? And what's the data that's really available to everyone, or the open source that's available on the web, right? So we're going to study those whole things and we're going to talk about them in the videos, right? So there are the fundamental guidelines, security design principles to create secure systems, ensuring confidentiality, integrity, and availability. CIA is basically a tried in, it's not just that CIA, but it's basically the main goal of this information security subject. Confidentiality means you should be confident about your system, integrity to protect the data, and availability, that the data should be available. These are the three principles of the information security, right? And they're really essential for developing policies, architectures, and defense mechanisms to protect assets from threats. Now, there's some principles to make them the secure design. So first one is least privilege, right? It means the users and systems should only have the minimum level of access required to perform their task. Really, what the topic, what the word itself says, because, we are using systems, but even in our own computers, you have sometimes encountered that administrator option where you're not allowed this access, or you're not permitted to access some files which are system related, and you mess up them, so it's not better to even touch them. So least privilege means that how much access you can give to a person, including in the system, right? So for example, in the WhatsApp is the most common example. We have some messages and they say it is end-to-end encrypted, means no one can see it. So it means that no one is saying it, right? So it means that the privilege is only given to me and the person who I sent that message to, right? Or for example, if you talk about an office setting where, some people are from sales department, some are from marketing department, already done an example, and they would have given access to their only the department information and the other information that they should know, not the whole company information for sure. Example could be a customer service representative should only access customer contact details and not the financial records. Because when you often talk, call these complaint centers and you give some call to them, they only know about your data, about the related, bank related data, and not really your financial bank related data, right? Or in the river example, they talked about in window users account control. Users operate with standard privileges and must provide admin credentials for system level changes. I told you these things that when I told you this thing just right that I told you this thing just right now that when they asked about your administrator controls, right? So this is called Windows User Account Control. It is UAC. Although it's written, it's just good for me to write them down myself so I can remember them better. Window, so I'm going to mark it as important so I can read it again. Okay. Window User Account Control, UAC. So basically our own accounts, or when we install them into our own PCs, they are all generally really important stuff that we encounter. So this one is an important one. So We do have privileges to some extent, but we can't just set all of the things, and that's why it's called window user account control. In cloud services, AWS, which is related to Amazon Web Services something, policies enforce role-based access control RBAC. This is also really important in terms of the offices we work, right? So for example, someone is working at a bank as a cashier, you would only have access to the data of the customers coming in, coming out. Maybe you would not have access to other departments like, related to operational managers or that, the big data about the organization or the events going on. You would only have the data which role-based access control. It is really, it is really a type of concept in the corporate. It's better to use corporate than office. Yeah, role-based access control. Ensuring the developers cannot modify security settings unless explicitly permitted, right? So the people should have only access to the data that they are going to be working in, right? So AWS IAM are some kind of rules, policies that is AWS in short, which is Amazon Web Services, right? So these were the two examples of least privilege. You can give it more that Windows user account control and role-based access control RBAC. When we enforce that into our workspaces, this is least privilege, and this also ensures security. What are we talking about the security? We're talking about the security of a company, right, of an organization who has some data, right? Fail-safe defaults. What this means, the default access settings should be denied unless explicitly granted. Although these two are kind of same, but this one is more explicit. A firewall blocking all traffic unless specific rules allow certain connections. For example, sometimes you search on web and it shows you that this is not the safe. You can go hide details, or you can choose advanced, and most of the time I choose advanced, and then I can proceed to the proceed to the web that I want to go. So in this case, there are some firewall which is blocking the traffic because it has really suspected that the website is not secure, so it can just steal my data. But when we think the advanced, I think it really applies some specific rules that really allow us certain connections to the web, right? So the default behavior is really modified in here. Linux file permissions, by default files are not executable unless explicitly changed. Apple's iOS security model apps runs in a sandbox with no permissions unless granted by the user. So when we buy a new phone or when we have a new laptop, it's not always the cases, sometimes even for this microphone setting, we need to really give permission to the microphone to really access it, or the camera to access our videos. So these are all generally, so the least privilege are mostly like for the organization type, but the fail safe defaults are basically for the user or the human with the uh, the right given to the user. Alright, what would be that I can choose who I want, who can access my sound, right? I can choose whether the PC or the site I'm using can access my camera, right? When we are often working on Google Meet on the web, they often ask us to the browser to access the phone or the video, right? So now I can enable that. So fail-safe defaults means the user can change the default settings of the default behavior, and he can change it, right? The tool I gave you the web example, default it was not going to open, but I opened it by using the advanced option, right? So this is the Linux file permissions. This means that the Linux operating systems work in this way, that some files may not be executable unless you really default, write the commands to make them executable. And some apps may run under some, may not run under some apps. In phone generally, in phone sometimes they ask us to kind of show that some permission in the settings to get on to really work through it, right? Okay, separation of duties. This is also really important, and this is kind of you can have searched about or learned about modularity in really context of the requirement engineering in the context of software development as well. So separation of duties in terms of security is also important because it helps to kind of divide the responsibilities rather than just juggling everything together. So dividing responsibilities among multiple users to prevent fraud and abuse. Because if one person is not loyal, maybe the other one is, right? If the second one is not, maybe the third one is. So maybe there, because of separation of opinions, we can be more safe about the people doing stuff, right? So in banking, the person who approves the transaction should not be the one who initiates it, right? So they say that not everything should be done by one person because there's more chance that the system will be corrupted by that one person, right? It's better to have multiple people involved so that one can really detect what the other person is doing, right? So my father is also a banker, and and sometimes they all work in teams. So sometimes it happens that the person who really to really point the transaction may have some difference in the money they deposited or transacted. So in this case, there's really a big responsibility on the team to really equalize the money together. So if some person may give transaction to this customer, may got the money from him or her, then the other person, the person who's really understand this concept, like the banker himself, can you know point that out, right? So it means that the person who is really initiating, they should work in kind of teams to enable a secure system. One example could be GitHub repositories, like developers submit pull requests, but only senior engineers can approve and merge them, right? Because uh, the separation of duties means you can do a lot of pull requests, but the developers would do and see, and then they would make a change because then it will be like a mess if everyone can make change. Financial transactions. Payment processing systems like PayPal require multi-level authorization for high-value transfers, right? So we were basically talking about the organizational duties here, but they're also talking about the generality here. So in the financial transactions, means we can just map this teamwork or the team point for the security to our software point as well. Means when we're really, authenticating and really transacting through PayPal, it really authorized the multiple times, right? So that it's really ensured now. They have also introduced this multi or two-level authorization across the sites we visit. That's really annoying because when you just visit the website, they then send you the mail and you need to confirm. It's big work, man. You just spend 10 minutes just signing up on a site. It's a big work, but they have introduced it because of the security systems. So this was the separation of duties, that you have responsibilities divided so that you have more chance of a secure system. Okay, defense in depth. Implementing multiple layers of security so that if one layer fails, others provide protection, right? So this separation of duties was also layers, people layers or software layers, one authentication above the another. But defense in depth is mostly generally in terms of the computing or technical detail stuff, that we should have one layer of security over another layer so that if one fails, we can have the other one. A network with firewalls, intrusion detection systems, and endpoint protection, right? So for example, if a network have firewalls, a certain, many firewalls, if one fails, other can work, intrusion detection systems, and endpoint protection. So means that, for example, if I'm using the HTTPS protocol or the secure for web browsing, and sending and, receiving the post request, whatever. So now this is not enough thing to do. I can also implement the firewalls. I can also have some intrusion detection systems or some other endpoint protections or authentication or validation on my own site if I'm running the domain. So if one fails, for example, my firewall fails, my authentication no. So at some point we're really going to able to detect the what we can say is vulnerability. Yeah. Okay. Real example could be modern cloud security. AWS security uses IAM rules, network firewalls, and encryption at multiple levels, right? So they use multiple levels encryption because they want, secure cloud, computing or secure web browsing, something like that. Zero trust architecture. Right. Companies like Google use zero trust to ensure no user or device is trusted by default. And this is really, important in case of when you are even developing code for your sites, because there's some measures that you can take to kind of prevent the user behavior. And there's this jargon in the programming and the computing industry in general that don't trust the user, right? Always make the necessary changes. Don't expect them to do what you want them to do. Always do apply the efficient practices so that you can be, you know, uh, safe from any type of attack. So defense in depth means you should have in-depth layers, but they're just really, kind of the same, but the more technical. In the separation of duties, we meant really that we should have more people, so we have more secure systems, and that will really mean the fail-safe states that the default should only be, modified by the user, right? So they're all kind of related together. Then we have kind of open design, which is security mechanisms do not rely on secrecy, but rather on well-vetted and open security principles. Example, publicly viewed encryption algorithms like AES. Signal messaging app uses open source cryptographic protocols and sign protocols to secure communication. Linux security, open source OS with constant public security and improvements. So what is open design? In simple words, we are going to understand this one here. So open design means that security systems should be built on transparent, publicly known principles rather than secrecy. The idea is that strength comes from strong design, not from keeping it secret. AES encryption is publicly available, yet highly secure because of its strong mathematical foundation, not because it's hidden, right? Securing through design, not obscurity, right? So this is the main idea that open design means that you should use, the more known algorithms for designing your security systems, but you should have strong foundations or strong mathematical computations or high computing power to kind of, implement them. You shouldn't have like, no, I don't know, very fancy algorithms you have implemented that other people really don't know about, right? They should have secrecy. This is also a kind of, a jargon in um, computing, that security through design, not obscurity. I just don't have the sense of writing great. Okay, and remember app like Signal messaging app uses open source cryptographic protocols like Signal protocols for secure communication. So what is the Signal messaging app basically? Signal messaging app tells the Signal to, the Signal messaging app it uses the end-to-end encryption to keep chats, calls, and files private. It's open source, doesn't store user data, and supports disappearing messages. Okay, so Signal is a secure messaging app. Like we have WhatsApp, but because we are so habitual with WhatsApp that we really don't know about the Signal, but Signal is also a secure messaging app, and it's used the E2E encryption standard which is end-to-end encryption standard, and we can also write like as end-to-end encryption like the WhatsApp do. And then it used cryptographic protocols like Signal protocol for secure communication, and even though you may not know, people in the industry know it. And Linux security used the open source OS with constant public scrutiny and improvements. Like Linux used the OS security system, right? Constant public scrutiny, but because people always check on it and give different advices for improvements, so they really make the public changes there, right? Okay. And then we have psychological. So open design was all about making sure that you're using the well-known technologies, but you have a well-vetted and designed, right? Psychological acceptability. Okay. Now, what is psychological acceptability? And one thing I want to tell you, the Signal has better privacy than WhatsApp or Telegram, right? And uh, okay. And I want to talk about this one, Linux security. So it uses an open source operating system. Okay, so we have a closed operating system, which is basically not available to everyone for use, and then we have a open source operating system which everyone can use, and Linux use that. Okay. Now, psychological acceptability. Security mechanisms should not hinder usability, or users will bypass them. Of course, man, when you are given something, right, you're given some right to do something with some data, like, this is really a general principle of psychology that when you are really, asked to not do something that is wrong, or you think something is difficult to understand, you just bypass it. People may beat it, but this is a general psychological thing that when we encounter something we can't get, we don't have time to. We just bypass it. So if the security mechanism are just really hindering the UI, or really, just making it lower, or just making it really slow, how would we use it? We will be ignored, right? So enforcing complex passwords without providing a password manager may lead to work security practices. Of course, man, right? Choosing password is going to be a big thing for us now. Apple Face ID provides high security with minimal user effort. You just gotta show your face. Google Chrome Password Manager stores complex passwords securely while keeping the authentication seamless. Sorry to say, but this is also not really good. I don't have any experience with Face IDs, but Google Chrome, I can't always say that it's good, because whenever you kind of open it and want to see the passwords that you have forgot a long time ago, it always again tell you, give me the password first, give me the password first. Man, it's not work that way, so it's a little bit annoying for that as well, right? So, although it says that they are really providing, Face ID could be easy, but I haven't tried yet, so. But yeah, but the Chrome Password Manager, no. Complete mediation. Every access request should be checked before being granted. Okay, so what we're talking about in this sense. A session timeout that requires re-authentication of an activity, require re-authentication for high-value transactions, AWS and Google Cloud Monitor access attempts, and enforce real-time authentication checks. You may notice that ChatGPT often asks you to reassign or whatever, the log up again or whatever system is logging again. Because, every access request, the complete mediation. What does it mean basically? Complete mediation. What is the idea behind it? Right? The idea behind it is that the every request, access request to a source must be checked every time to ensure it meets security policies, right? Every time, for example, a user tries to read a file, the OS verifies permissions not just once, but on every access, right? So, for example, when I'm accessing a source in my own operating system, or when I'm accessing a source on the web, it should check that is the resource good for me, or am I accessing the right resource? As I told you the early example, that when you search for something that's not, the the right, the data, which is really not private, or not the ones that we really wanted, then what really happened is they asked you an option for advanced, where you really access the advanced policies, right? So complete mediation is basically seeing what the user is basically tracking us, right? That's why we have histories in which we have, where we did access websites and they control the privacy and the access that we have to the sites that we, for example, a session timeout that requires re-authentication after inactivity. For example, maybe I have Instagram on web. I used it and then I just forget about it for 2 months, and then I open it again. So it will ask me to re-authenticate myself after. Oftentimes, Cloudflare and LLMs like ChatGPT and Claude ask you to say that this may tell us that you are not a robot or verify that you are human, right? So these kind of modifications after some session to really make sure that AI thinks that you are human, right? Okay, your example. So banking apps requires re-authentication for high-value transactions. Cloud Access logs AWS and Google Cloud monitor access attempts and enforce real-time authentication checks. Google Cloud Monitor. I haven't any experience for between two of them, so I can't say anything about them. But authentication is usually done. Complete mediation. Least common mechanism. How many are there? So there are 10 basically. Okay. Systems should minimize shared resources to reduce the risk of security breaches. Right. So for example, like there are two computers. These are mostly given examples in the type in network context, and there are 3 or 4 computers which are using the same resource. So it's most likely that the hacker or whenever the attacker may access the resource from one computer, and then he can attack the other computers as well. So make sure that you have less shared resources. So for example, instead of shared accounts, each user should have individual credentials. What do it mean, shared accounts? Do we have shared accounts? Real examples: multi-tenant cloud security. AWS and Azure ensure isolation between customer data in cloud environments. Virtual private networks (VPNs) prevent different users from sharing a common insecure connection. Right. So I think the least common mechanism um, is the principle that really help you to kind of also make the modularity principle work as well, because it asks you to really minimize the number of resources that you are sharing. And to give an example that's more concrete and more to the idea of the least common mechanism, is that instead of a shared password databases, use the individual authentication tokens for each user so that we can prevent the breach from compromising all accounts, right? Maybe I have a database in which I'm storing each person who is logging to my site, and I'm using the password and storing the password there. Instead of that, more, the individual authentication tokens. What are the individual authentication tokens? They are basically authentications or the customizable. They are basically the unique or user-specific credentials which are used for verifying identity without sharing a common authentication mechanism, like API access tokens in Google or Facebook logins, OTPs or biometrics or smart cards. So in most of the time, when we are really, getting faster with our problems and faster with our data and the technology, we are really preferring that we are really authenticating the individual by the specific quality they have, like your mole on your face, or your face ID, or your biometric, or your smart cards, or your tokens, or your country ID, or we call it the national ID. They use it to authenticate you. Sites don't use that, but of course they use OTPs too, which is a one-time password they send you for verification. They use OTPs to basically kind of authenticate you, and in this case, the least common mechanism tell us that we are not, passing the same password to the same person, and we are not putting their, um, putting their names in the databases, and then just we're querying the name. Okay, for Aisha, she signed into this site, and then you're seeing the whole database for the name Aisha and this password. This is much more expensive, because of course we do it in some ways, but we can reduce it using those other more efficient token stuff and passwords and biometric and fingerprint scans as well, right? Okay, so now these are the things I can kind of munch here because, wait, where can I put it? Okay, now let's see. We have now real example like multi-tenant cloud security. AWS and Azure ensure the isolation. They use the customer data and they use tokens, which as I told you, like OTPs, to ensure that resources are not shared like a database. And VPNs also really protect, that the people. So virtual private networks are really used to access the data from the other countries. So if something, this is commonly used for banned apps, right? If some country and if the ban is if some app is banned, like the Twitter was. Previously, we used to use the VPN to access the Twitter. I still do. So, so in this case, the virtual private networks are useful, but if a lot of people are really, you know, virtual private networks have some opinions to them. Some just say that they are insecure, that they really breach data. They do. Sometimes they do breach data, but people have found the good VPN services to work for. I also use one. I don't recall the name, but VPNs prevent the different users from sharing a common insecure connection, so that you know what it means is it gives some, I think, the IP address to some users so that it can access the data from other countries. Yeah. Economy of mechanism. Security systems should be simple and easy to audit. Of course, for non-technical teams as well. A formal rule should be concise and easy to understand, not overly complex, right? Really important for non-technical people. Technical people, of course, will get it. Secure APIs well documented and minimal API endpoints reduce attack surfaces. Blockchain technology, simple, verifiable cryptographic mechanisms enhance transparency. Right? So it means economy of mechanism. How you are really implementing the work you tend to perform, right? So it's better to always make your security systems more secure so that it's better to audit them, modify them, and better to understand for people which are not technical. Especially the blockchain technology, you should have simple and verifiable cryptographic mechanisms enhance transparency, right? Although still you need to have some knowledge to understand this cryptographic thing, but still it's important to have your mechanism quite documented and better written, right? We're not saying that we shouldn't use formal language, but we shouldn't use overly complex language. Work factor. The effort required to break security should exceed the value of the asset being protected. So, for example, AES-256, which would take billions of years to brute force. Whoa. Bitcoin mining security, really, there are questions being asked about that as we are really progressing into big, computing chips and the supercomputing thing, quantum computing, uh, the people who are really in the Bitcoin and these blockchain and the mining, they are in some kind of doubt of whether the supercomputing or the quantum computing is going to take over the encryption standards for them really soon. They are talk about them that because they are really Bitcoin and this blockchain technology has really great mining algorithms, and only the supercomputer would be able to the quantum computer would be able to kind of process them. So there are questions being raised these days. So it says Bitcoin mining security. The computational cost of altering blockchain transaction is prohibitively high, and that's what supercomputer will be able to do it. Multi-factor authentication increases the efforts for attackers to compromise accounts. So one factor means you should have more value to the thing you are going to protect than the effort which is required to break security, right? So of course, if you're really trying to protect something, it should be worth the work, right? It should be worth the work that, for example, for Bitcoin, it's really important, and Bitcoin and this blockchain thing, it's really the data that they are really protecting through mining stuff, right? So if we're really putting power into it, the work into it, it should be that the hacker or the attacker should be really putting their efforts out to um, do brute force on them or to really decrypt or whatever you want to do. So this is an ASCII representation of defensive paths. Means we should have layers, which is physical security. We should have biometric access, security cameras. Then we have data security. We have encryption and access controls. Network security, of course, VPNs, ID, IPS, the IPs, calls, firewalls, and then host security for antivirus, patching, firewalls. Application security for APIs, multi-factor authentication, and secure. So we can go from top to bottom to understand this. We sign up here and we have multi-factor authentication. Then we go from host who has firewalls attached to it, and the network has VPN, and then it sends our data encrypted. And then the physical security, there are biometric access and security cameras. So this is also important. And defense in depth is the layers of security protect assets even if one layer is compromised, right? Now we will study the more modern trends of the security design principles in 2025, what we will do in the next one.